Welcome to Unacademy, the largest online e-learning platform, and welcome to Unacademy Semester Exams. Today, we'll be discussing graph theory under circuit theory course. It is a crash course, lecture 12. So before that, let me tell you about myself. I am sravan Kumar, having 7+ years of teaching experience and mentored more than 5K students for GATE and engineering services and cracked GATE. Let me also tell you about the Unacademy in learning app installation procedure. Type Unacademy learning app in Google Play Store. You will get this. Click on this. Then you will have to select GATE and engineering services for GATE students. And you can click on this plus and click on this get subscription. And you'll have two types of subscriptions. One is the plus, other one is the iconic, wherein you'll get a dedicated mentor for your preparation under iconic. You can use my code as YSK10 to get the maximum discount of 10% and click on this proceed to pay. You'll have the payment platforms like debit card, credit card, EMI, UPI, wallets, net banking. You can use any of these platforms and get subscription to the Unacademy. Now, Unacademy has come up with Evolve for GATE 2022 Electrical Batch A in English and Hindi, and it starts on December 21st. Ankit Goyal sir, as you know, All India topper, first rank, Ajay Gupta sir, Hafiz sir, VV Reddy sir, and Suresh sir. They'll all be available for you guys to teach GATE 2022. So you can opt for this, you can join us and learn and crack GATE 2022, which is very much helpful for the students of which is very much helpful for students of third year right now who are about to rise, and also students who are willing to write the next GATE exam. So good evening Swarnasri, good evening Arvind, good evening Vijay, good evening Vasanta, good evening Chaitanya. Sure, sure, Chaitanya. Thank you so much. Thank you for your concern. So let me discuss about Unacademy Combat. Unacademy Combat is India's largest fortnightly competition for GATE and best questions by the best Unacademy educators. And we have come up with challenging questions curated by our best Unacademy educators, question guaranteed to keep the test engaging, challenging, and fun. Also, you'll have super fast and fun with real-time ranking system. See how you rank against others with live leaderboard after each and every question, and you will compete with the best and know where you stand among those other contestants. And you'll have the detailed solutions of the questions by the top educators. You'll get in-depth video solutions for the questions right after the contest, and you can compete, crack, and conquer. You have score, leaderboards, live rating, and awards. Let me tell you about these awards. Compete with the best and win amazing awards like Apple MacBook Air as the first, and second prize Apple iPad Mini, and third prize Apple AirPods, and top 100 rankers would get rupees 1000 Amazon vouchers. Nikhil Chakravarti, good evening. Welcome to Unacademy and Circuit Theory Crash Course. Let me summarize about Unacademy Combat. It is on December 16, 6 p.m. So register now and you can enroll for free. It is India's largest fortnightly competition for GATE. We have challenging GATE questions created by best educators, super fast and fun with real-time ranking, compete with the best, and you'll have detailed solutions by our top educators, and you can win exciting prizes. As I have told you, the first, second, third, and top 100 rankers will get this. So coming to today's topic, today we'll be discussing Cutset matrix and Cutset matrix. Today we'll be discussing Cutset matrix and Cutset matrix. It's a part of circuit theory course and a topic under graph theory, or it is also called as topology, network topology. So let us discuss about that. So yesterday, let me revise what we have done yesterday. Yesterday we have seen what is a graph and what are nodes and branches in that graph. Then we have discussed what is a tree, what is a core tree, and what are twigs, what are links, and number of twigs and number of links, number of links and number of twigs even. Then I also told you about incidence matrix, which has two, there are two types of incidence matrix. One is complete incidence matrix and the other one is reduced incidence matrix. So this is what we have learned yesterday, and the size of these matrices, complete incident matrix was represented by AA and reduced matrix by A, and the size of this was n by b. You can also write it as small n by b. So let me write here, size of complete incident matrix is n by b or small n by b, and size of this reduced incident matrix was n minus 1 by b or capital N minus 1 by b. Shivkumar, good evening. Raju, good evening. Welcome to circuit theory, and we are discussing graph theory today, the continuation of the previous session. So these are the things that we have discussed yesterday: graph, node, branches, tree, code tree, twigs, links, number of links, number of twigs. Also, we have discussed what is incident matrix, complete incident matrix, reduced incident matrix. Apart from these, I also told you how to draw graph from incidence matrix. This is what I have discussed in the previous session. So once again, students were asking me about the quality. I'm just discussing once again on your screens, on your screen which you are watching. If you are using a mobile, on your screen like this, where you are able to see me, on the top right corner, on the top right corner, if you can just touch your screen, there are three dots. Just touch it, click here. There is a pop-up, you'll find, you'll have a pop-up here down, wherein you'll find one is report, the other one is quality, next you will have captions, then you will have playback, and so on. You'll have two more. In this you have to click on this quality. Quality, probably it is set to 144p, so it also has 240p, 360p, and you need to select 480p. Select this. Then the quality of the video that you are watching, the quality of the video that you are watching will be better, better, or you'll be clearly able to see that, and that's the visibility. So this is what you have to do. All right, so please do change your settings, that's very important. Click on these three dots, you'll have a pop-up like this. Click on this quality, and you have many options there. Click on the highest one that you have. You may also have 480 plus somewhere if somebody is using some other. You'll have this quality. Click on the highest quality, you'll have the better quality of my video. So next, so today we will discuss what is Cutset matrix and also Cutset matrix. So before getting into Cutset matrix, let us try to discuss what is Cutset matrix today. It is also named as फंडामेंटल सर्क्यूट, इसको क्या बोलते हैं, और फंडामेंटल सर्क्यूट भी बोलते हैं इसको, और इट इज ऑल्सो कॉल्ड एज एफ सर्क्यूट. These are the names that are given to this टाइसेट. इसको ऐसे भी बुलाते हैं, टाइसेट को फंडामेंटल सर्क्यूट भी बोलते हैं और एफ सर्क्यूट भी बोलते हैं इसको. देन Let's see what is that. Now let us consider one example, and with that example I'll try to explain you. Let us consider an original graph first. What is fundamental circuit? I'll tell you. Original graph, let us take this, the standard one that we are taking. Let this be the original circuit. So let this be the original circuit. And also this is A. Let us call this as B, C, D, E, and F. This is one node, this is second node, this is third node, this is fourth node. So this has number of nodes is equal to 4 and number of branches is equal to 6. Now to this, let us draw one graph. Let us try to take one graph first. I'll take one graph. So this can be one graph. So let us consider one graph. This is the graph. This is the original graph. Let us consider one tree. Let us consider one tree. This is the tree. What is this? This is a tree. This is a tree. Now this tree has first node, second node, third node, fourth node, all the nodes it has. So n is equal to 4. So tree is an improper subgraph which has all the nodes of the original graph connected to each other but no closed path. So if you can see this, this does not have any closed path. So let us name them, this as B, this as C, and this as E. Now what is F loop or F circuit is? Now, what are these BCE called as? Let us also name them first. Let us write what are BCE. And in this tree, how many number of nodes are there? 3. How many number of twigs are there? Number of twigs is equal to 3. Number of links is equal to also 3. Now, what are twigs? What are twigs in this? What are twigs? B, C, E are twigs. What are twigs? The branches of a tree are called as twigs. So, B, C, E are twigs. Now, what are links then? What are links? Links are also called as cords. Links are also called as cords. Now, what are the cords? So the total number of branches here are A, B, C, D, E, and F. Now in this, if you observe B, C, E are twigs. The rest of A, D, F. So A, D, F are called as A, D, and F are called as links. These are called as twigs. These are called as links. Now if you place a twig, if you play, these are already twigs, right? If you place a link, let us place one link. Let us take one link first. This is A. Where is A? This is A. Let us place that link. What will happen? If I place this link here, if I place this link here, this is forming a closed path and you need to take the same direction. A. So the loop that's formed by placing a link onto a tree is called as the F cut set. And you need to consider a loop F circuit loop current, that is I1, which is same in the direction of, this is also called the tie set direction. This is also called as a tie set, and the direction of this tie set is same in the direction of the link. This direction must be same as that of the link. So now second one, let us take the second one. What is the second link? This is the second link D. Where is it? Here. Place that. If you place this link, now what is happening? There is again a loop that is forming, and take that loop I set direction as D. So this is, let us call this as I2. Now what is the third link? F. Place that F also. This is F. Place that F and take these directions. And this is called as F. And the direction of loop current in this, or the direction of currents, will be I3, or tie set is I3. Now let us take this to the next slide and see what we have to discuss about this. So in this, if you observe, first write what are twigs. What are twigs? What are twigs? B, C, E are twigs. What are links? A, D, F are links. Now we we should be able to tell that number of tie sets is equal to number of links. How many number of tie sets you'll get? How many number of as many number of links as you have. See, if I have 5 links, if I place 5 links, there will be a closed path, and that will be number of tie sets. So in this number of links, how many number of links are there? 3. So therefore number of tie sets will also be 3. So let us write those tie sets and their directions. Let us write tie set 1, tie set 2, tie set 3. Let us write 3 tie sets. So what is tie set 1? We can also, in some textbooks, you will also call it as I1, I2, I3. Now what is tie set 1? Tie set 1 is this first tie set. Tie set 1 is corresponding to A, let us say. So what are the branches in this tie set? That means what is a closed path which has branches? This loop is called as the tie set. Now this complete loop. What are the branches in that? A, B, C are the branches of this tie set. What are the branches in the second tie set? I2. These are the branches. What is this? C, E, D. C, D, E are the second tie set branches. Third tie set branches B, E, F. B, E, F are the third tie set branches. Clear? Hope this point is clear for everyone. So this is the first tie set, this is the second tie set, this is the third tie set. With this information, you must be in a position to form a tie set matrix. Generally, tie set matrix is represented by B, and a tie set matrix has it has rows and columns, and rows are nothing but the number of tie sets. How many number of tie sets are there? How many number of tie sets are there? The number of tie sets is equal to number of links. We do not know any size of tie set, so we can write what is link b minus n plus 1, and by it is b minus n plus 1 by number of branches. How many number of branches are there? 6. So it is b minus n by b minus n plus 1 by b. So what are the rows here? Tie sets. Tie set 1, tie set 2, tie set 3. What are these branches? A, B, C, D, E, and F. Now, how should you fill up these branches? These matrix is, first consider I1. What are the branches in I1? A, B, C. That means you'll have A, B, C values, except that the rest of the values will be 0. Now check, is I1 direction and A direction same? I1 direction and A direction. See, I1 direction is in this direction, A is also in this direction. Write +1. Now look at I1 direction and B direction. I1 is in this direction, B is in this direction. Both are in opposite direction. -1. Also, I1 is in clockwise direction. C is opposite to that. So this is also -1. Now let us consider the second tie set. Second tie set has a C, D, E. Draw the second tie set separately. Let us take this as second tie set. See, this is the second tie set. What is the loop in this? This is the loop direction, that is I2. Now what is the direction here? C here, this is E, and this is D. Now if you look at C, D, E, so A, B, F values will be 0, because tie set 2 has C, D, E, and except C, D, rest of the values will be 0. So now what is the value of C? C and I2. If you look at C and I2, both are in same direction, so this is +1. If you observe D and I2 also, D and I2 will obviously be, because I have taken I2 in the direction of D. Therefore, I2 and D will always be +1. And if you observe E and I2, both are in opposite direction. See, downward is the direction of E and I2 is in the upward direction. So it is -1. Similarly, consider I3. I3 has what are the branches? B, E, F. Except B, E, F, rest of the values A, C, D values will be 0. So what is the value of B? Is B in the direction of I3? If you see, I3 and B both are in the same direction. So B is +1. And if you observe E also, it is also in the same direction, +1. If you observe F, it is in the minus direction, opposite direction, -1. So let us conclude some points from this and see what is will happen in the next. from this you can say, get the chat one, let me check. Good evening, Soumya. Now, from this you can say this is tie set, the tie sets, and these are branches. That means you'll have, for a tie set matrix, this is the matrix. You'll write tie sets in this direction as rows and branches in these directions as the columns. All right. So the size of this matrix is b minus tie set, number of tie sets b minus n plus 1 by number of branches b. So this is the size of the tie set matrix. You just need to remember that once again. Now from this matrix, let us write b as links and twigs separately. What are the links in this? What are the links? Twigs. Let us write twigs and links separately. Let us first write twigs, b c e. So first I'll write b column, this column b c e. B C E are what? B C E are twigs. ADF. ADF are links. BCD. BCE are, BCE are, what are BCE? BCE are twigs. So these are twigs. I'm writing twigs columns first. Then I'm writing links columns. So what is B? Minus 1, 0, plus 1. And C? Minus 1, plus 1, 0. E? 0, minus 1, plus 1. If you can observe this column. Now write A. What is A? Plus 1, 0, 0. D? 0, plus 1, 0. F? 0. Now just take this. Now if you look at I3, I3 direction is taken in the negative. So I3 must be taken in this direction. See, I3 and F must be in the same direction, right? I3 and F must be in the same direction. So if you take that, I3 and F, if they are in the same direction, here the value, here a small mistake. Yeah, you have to remember this. Now if you take I3 and F in the same direction, I3 must be in the direction of F. So both E and B will be in negative direction, that is in the opposite direction. F is positive. So this is, so what are the values? Minus 1, minus 1, plus 1. So this is minus 1, minus 1, plus 1. So what is B? B is minus 1. And D? D is also E. E is also, yeah, this value and this value will be, this is also minus 1, this is also minus 1. F? F is plus 1. Now if you observe this, I have written this as B twigs and B links. So this is twig matrix, this is link matrix, and link matrix is always in a tie set matrix. Link matrix is a unitary matrix, 1 0 0 0 1 0 0 0 1. So B is equal to, you can write B twigs and unitary, B twigs and unitary matrix. So let us summarize the, Rashekar, good evening, welcome to circuit theory crash course. Let us summarize the points in tie set matrix. It gives the relation between, actually it gives the relation between the link direction and the other branches direction, tie set direction and other branch direction. It is denoted by B. The size of a tie set matrix, the size of a tie set matrix is B minus n plus 1 by B. B minus n plus 1 by B. This is one more point. B matrix is always represented as B twigs and unitary, which is also B twigs and B links. That means in a tie set matrix, B links is unitary matrix. B links is an unitary matrix. Also, very important, number of tie sets is equal to number of tie sets is equal to number of links. Number of tie sets is equal to number of links. Number of tie sets is always equal to number of links. And loop tie set direction. Tie set direction is taken same as link direction. This is very important. These are very important points. So this and these points are very important. These 2 points are very important. These 2 points are very important. These 2 points are very important. Number of tie sets is equal to number of links, and the tie set direction is taken same as, or loop current direction is taken in the same direction as that of the link direction. Hi Rashekar. So this is about tie set matrix. Now let us solve one problem by using this tie set matrix concept. Let us say there is a question given to us. Let us consider one question. I'm considering one question from one of the textbooks. Yeah, let us consider this question, and the question is, find tie set matrix for given question or given graph, sorry, for the given graph. And the graph is given something like this. To have a line like this, there is another one, there is one more, there is another like this, there is another graph that is given, another one, there is one more given like this. So this is what is given to us. I'm sorry, this is one node, this is the other node, this is the third node, and this is the fourth node. Also, what is given is the directions are given and branches are taken as numbers. This is 2. Let's call this as A, B, C. Nodes are A, B, C enough. This is 2 and this is given as 5. We can take anything randomly, but let us take according to the given question. This is 4 and this is 1 and this is 6 and this is 3. 1, 2, 3, 4, 5, 6. Right? So the good evening Anup Sagar. The first one that you need to do is, for any given question from the original graph, write number of nodes. From here I'll be writing nodes as number of nodes. Number of nodes n. I'll be writing small n. Number of nodes is equal to 3, 4. A, B, C. There is also D. Number of nodes are A, comma B, comma C, comma D. 4. Next, write number of branches. Number of branches. B is equal to, how many number of branches are there? How many number of branches are there? 6 branches. 1, 2, 3, 4, 5, 6. 6. What are they? 1, 2, 3, 4, 5, 6. How many number of branches are there? 6 branches are there. How many number of nodes are there? 4 nodes are there. Now, let us consider one tree. See, in order to have a tie set matrix, for an incident matrix, you don't need a tree. For an incident matrix, you don't need a tree. But for a tie set matrix and cut set matrix, you definitely have to draw a tree first thing. First, you need to draw a tree. So let us consider one tree. You can consider any tree. Now I'm considering only one tree. This is the tree that I have considered. Let us say this is the tree that I have considered. So this is the tree. So let's suppose this is a tree and this is a node. This is a node. You have to check whether the tree taken by you is satisfying the condition that I have told you. A tree must have all the nodes, right? So A is present, B is present, C is present, and D, and everything must be connected at least once. And what are these? 4. And what is this? 5. And this is 6. Now can we write twigs? What are twigs from this? What are twigs? 4, 5, 6 are twigs. Twigs are the branches of this tree. And what are links? And links are the branches that are removed. What is removed in the between these two? 2 is removed. And in between A and C, 1 is removed. In between B and C, 3 is removed. That means 1 2 3, you can write them in the order 1 2 3 as links, or they are also called as chords. They are also called as chords. Now you have written these links and chords. Now what is the matrix B? B is the matrix, Cutset matrix. Now you should write size of the matrix. What is the size of the matrix? It is number of twigs. How many number of twigs are there? 3. How many number of links are there? 3. How do you get number of twigs? N minus 1. How do you get number of twigs? Small n minus 1. N is 4. 4 minus 1 is 3. How do you get number of links? B minus n plus 1. What is B? 6 minus n. N 4 plus 1 is 3 again. So number of twigs is 3. Number of links is also 3. So what is the size of this matrix? It is links by branches. It depends upon the links. So what is the links? 3. Branches 6. So the matrix size, the Cutset matrix size is 3 by 6. The matrix size is 3 by 6. Now let us consider these two. This in the next slide, and here it is 2, 3 and 1. So let us consider this tree in the next slide. Yeah, let us take this tree. So this is the tree. Now how do you find? So just try to draw one by one. Draw this again and again. Just try to draw this 3 times. Yeah, this is the second. And also let us take one more time this. This is the third. Now add one by one. What are the links now? Let us take what are the links now. Links are 1, 2, 3. Add one by one. Let us first add 1. Where is 1? It is, where is 1? 1 is between A and C, and it is in upward direction. So this is 1 is added to this. It is between this two, and it is in the direction of, it is in which direction it is? From C to A. Now let us add the second loop. What is the second branch? 2. Where is 2? Just observe, it is between A and B and in right side direction. It is between A and B and in right side direction. This is 2. And let us add the third branch. Third branch is between these two, B and C in downward direction. Let us add that B and C in downward direction. B and C in downward direction. This is the direction. So what is this value? 3. So here we have added link 1. Here add link 2. Here add link 3. We have done this. Now how do you get that link matrix? Let us Cutset matrix. Let us see. So let us consider this matrix. So this is matrix B. And what is the size of the matrix? 3 by 6. Why 3 by 6? The number of links are 3. What are they? 1, 2, 3. So you need to consider a loop current here. You need to consider a loop current here. This is the loop current. This is the loop current, and it must be in the direction of first one. So this is I1. And this is I2. If you observe, this is I2. This loop current is I2. Then this loop current is in the direction of 3, that is I3. So what are these? You can type T1, T2, T3, or you can also write I1, I2 and I3. And what is the other one? These are branches. What are the branches now? 1, 2, 3, 4, 5 and 6. How many number of branches are there? 6 branches. We have written here, right? 1, 2, 3, 4, 5, 6 are the branches. Now let us see in first one. In first one, let us write one by one separately. Let us write one by one separately. Let us write one by one separately. In this Cutset one, what are the branches? This is it. Then you need to consider this loop. What are the branches that are present in this? 1, 4 and 6. Except in I1, that is in I1, how many number of branches are there? 1, 4, 6. 1, 4, 6. Except that the rest of the values are 0, 2, 3, 5. 1, 4, 6. Except 1, 4, 6. 2, 3, 5 will be 0. And you need to consider this 4, this loop current direction I1 and 1, both are in same direction, plus 1. Both are in same direction, therefore this is plus 1. Now if you observe 4, it is also in same direction. See, it is in clockwise direction, so this is also plus 1. And 6 is also in plus 1, so 6 is also in the same direction, plus 1. Now let us write I2, that is tie set 2. In tie set 2, what are the branches that are present? 2, 5 and 4. So 2, 5, 4 and 5. What are that they are present? 2, 2, 4 and 5. Vignesh Chari, good evening sir, good evening. So you have 2, 4, 5. So except 2, 4, 5, rest are zeros. 2, 4, 5, rest are zeros. Now what are the values? I2 and 2 are in same direction, plus 1. This is loop current I2 and 2, both are in same direction. And 5 is in, like, see, if you see I2 is in clockwise, 5 is in anti-clockwise. It seems something like an anti-clockwise, so it is minus 1. And if you observe 4 also, 4 is also in opposite direction, so it is minus 1. 4 is also in opposite direction to I2. Now let us consider loop 3. Here tie set I3 or tie set 3 as what are the branches in this loop? 5, 3, 6 or 3, 6, 5 and 6. Except 3, 5, 6, rest of the values are 0, 0. Except 3, 5, 6, rest of the values are 0. Now let us write the values. 3, let us look at 3 and I3. This is I3, this current, the loop current is I3, this loop current is I3. I3 is taken in the direction of the link, therefore I3 and 3 are in same direction, plus 1. Now if you observe 5, 5 is also in the same direction, so it is also plus 1. Now 6 is in opposite direction, so it is minus 1. So this is how you will find tie set matrix. And to check whether this is correct or not, just simply take this. I'll just take this to the next slide. And write this in the form of links and twigs. What are the links and twigs? That will depend upon the tree that you have taken. What are links and twigs? That will depend upon the links, and that will depend upon the tree that you have taken. What are the twigs in this? What are twigs that in the tree that I have taken? 4, 5, 6. What are the links in this? 1, 2, 3. That depends upon completely on the tree that you have taken. So in this, the twigs are 4, 5, 6, and the links are 1, 2 and 3. The links are 1, 2, 3. So let us write in the form of twigs and links. First I'll write twigs, then we'll write twigs. What are the twigs? 4, 5, 6. Then we'll write links. What are the links? 1, 2, 3. Nothing but these columns. We are just writing these columns. So what is the fourth column? Plus 1, minus 1, 0. Plus 1, minus 1, 0. This is I1, I2, I3. What is the fifth column? 0, minus 1, plus 1. See fifth one, 0, minus 1. And sixth, plus 1, 0, minus 1. What is the first? Plus 1. See, first is plus 1, 0, 0. Plus 1, 0, 0. Ramchandra Kumar, good evening. Welcome to Circuit Theory Crash Course. Second, 0 plus 1, 0. 0 plus 1, 0. And third one, 0, 0 plus 1. 0, 0 plus 1. Now, if you observe this link matrix, it is an unitary matrix. Therefore, B is equal to B twig and unitary, which is satisfied. Therefore, the matrix that we have got is correct. So, and B is the tie set, required tie set matrix. This B is the required tie set matrix. So this is how you will get tie set matrix. This is how you will get tie set. This is how you'll get the tie set matrix. If you have any doubt, you can ask me. This is how you'll get tie set matrix. So just try to join Unacademy Combat and also Evolve Gate 2022 for third year and final year students. First join Combat on 16th of December 2020. You'll have live learning, live test, and best solutions by our Unacademy educators. Also, you can join Evolve 2020 on Unacademy. So these are the things that we have seen. Die set matrix summary. I have just given you the complete summary of the die set matrix, how it is represented by what is that size, what is the number of tie sets, what is the direction of the loop currents, everything. Now let us see what is a cut set matrix. Let us see what is a cut set matrix and try to find, apply that method. So cut set matrix. What is it? It is a cut set matrix. A fundamental cut set or F cut set, it is also called as fundamental cut set matrix. Okay. So in this matrix, generally this matrix is denoted by Q. This matrix gives the relation between, this matrix will give the relation between the cut sets and the directions of branches. It is denoted by Q, and this is based on Twix. That is based on Twix. That is, number of cut sets will always be equal to number of twigs, and a cut set must always contain one twig and any number of links. Must always contain one twig and any number of links. So this cut set actually divides the graph into two parts. Cut set divides graph into two parts. It is denoted by Q, and it is based on twigs. Number of cut sets is equal to number of twigs, and a cut set always has one twig, must always have one twig and any number of links. So this is the basic idea of a cut set. Now let us take one example and see what exactly is cut set. How do you find cut set for a given graph? So let us consider one question. Find or obtain cut set matrix for given graph. And the question graph is something like this, the same graph that we will take. So this is the graph, and let us take these values. This is, let us say this is A, B, C, D, F, and let us mark the nodes as 1, 2, 3 and 4. So if you observe this, first you need to write number of nodes. How many number of nodes are there? One number of nodes are there. Number of nodes n is equal to 4. Next, write number of branches. How many number of branches are there? B is equal to 6. Now, as we have obtained a tie set, cut set matrix must also be obtained from a tree. You need to consider one tree. Let us consider the same tree that we have considered in the previous say. Now, if this is the tree, now these are, this is B, this is C, and this is E. Therefore, what do you call this? BCE, BCE are called as twigs, and what are links? A, D, F are called as links. So how many number of links, twigs are there? 3. And how many number of links? 3. Now what is, if you draw this, if you just represent this links here on this same one. Now what are these directions of this A, and this is F, and this is D. Also we should note the nodes 1, 2, 3 and 4. Now what are cut sets is, cut set is dividing the graph into two parts. So you can make a cut set should always contain cut set. You mean you need to cut the graph. So you can cut a graph like this, separating this node. And this cut set C1 is, if you observe this cut set C1, it is touching branch A, branch B and branch D. Now cut set C1, let us write here cut set C1. Cut set C1 has, what are the branches that it has? A, B, D. You are dividing the graph into two parts. You are separating these three. Now in this, if you see, B is a twig and rest of AD are links. That was the point that I told you. A cut set must always contain one twig, only one twig and any number of links. Any number of links. So it has one. Similarly, if you observe, you can also cut this graph, separate this like this. So for C2, you have cut set 2. This is the cut set 2, C2. So this cut set 2 has, what are the branches that this cut set 2 has? A, C, F. A, C, F. And you can also have the other cut set. The third cut set is this one. What is the third cut set? C3. So C3 is cut set C3. What is cut set C3? It has what branches? D, E and F. So let us take this to the next slide and try to solve much more about this. So for each and every twig, so what are the twigs here? Just observe. What are the twigs? Twigs for the taken graph B, C, E. For each and every twig, you need to draw a cut set. For each and every twig, you need to draw a cut set. For C, for B, cut set 1. For C, cut set 2. For E, cut set 3. And C1 has A, B, D branches. And C2 has A, C, F branches. And C3 has D, E, F branches. C3 has D, E, F. C2 has A, C, F. Right. Now you need to complete the matrix Q. What is Q matrix? What is Q matrix? It is a cut set matrix. Now, how do you determine the size of this matrix? See, the size of the matrix is number of rows is equal to the number of twigs. It is n minus 1 and number of branches is B. So the size of die-set matrix, sorry, the size of cut set matrix is size of cut set matrix is equal to n minus 1 by B. So what is n minus 1 here? 4 nodes are there. Minus 1 number of twigs, that is equal to. So that is 3 by 6. B is branches. Number of branches is equal to 6. So you will take C1, C2, C3. C1, C2, C3 are C1, C2, C3 are cut sets. Number of cut sets is equal to, as I told you, number of twigs. Number of cut set is equal to number of cut sets is equal to number of twigs. And these are A, B, C, D, E, F. No, branches. These are branches. Now C1 has A, B, D. C1 has A, B, D. So the rest of the values will be 0. C1 has A, B, D. Now let us look at, now what is the direction of this cut set? The direction of cut set is always in the direction of twig. The twig B is in the right side direction. So this also has, C1 also has right side direction. That is, it is moving away from this cut set. Now if you observe A, B, D, all the three are also, A is also moving away if you see. D is also moving away. B is also moving away. So if everything is in the direction of B, so this is plus 1, this is plus 1, this is also plus 1. Srilata, good evening. Karthik, good evening. Now if you observe C2, now if you observe this C2, this is C2. And C2 direction should always be in the direction of the twig. So C2 is in the direction of C. A is also in the direction of C. But if you observe F, F is away from C. F is away from. So A is positive, C is positive, F is negative. A is positive, C is positive, F is negative, and rest of the values will be 0. Now if you take the cut set 3, take this cut set C3, C3, this is cut set C3. It has D, E, F, except D, E, F, except D, E, F, except D, E, F, A, B, C values must be 0. Now look at D, E, F. Are they in the direction of this C3? And C3 direction is taken in the direction of E. See, if you take C3 and E, both are in same direction, so plus 1. Now is D in the same direction? If you observe here, D is also in the same direction. Therefore, D is also plus 1. And write F. F is also in the same direction. This is also plus 1. This is also plus 1. Okay. Now, let us write this matrix as twigs and links. Let us write this matrix as twigs and links in the next slide. So, this is the matrix Q that we have obtained. And for this matrix, we already know that what are the twigs. What are the twigs for this matrix? It is B, C, E. Just observe here, B, C, E. The B, C, E are the twigs. So, if B, C, E are the twigs, what are the links then? A, D, F. So let us write the matrix Q clearly. Let us write matrix Q clearly. Q is equal to, let us write all the elements in twig and link form. So let us write this first as B, C, E. Twig I am writing. So this part is B, C, E. And the next part is ADF. So what is a B column? B column, if you observe, this is plus 1, 0, 0. And this is C, 0, plus 1, 0. E, if you observe, 0, 0, plus 1, 0, 0, plus 1. A, if you write, this is plus 1, plus 1, 0. D, if you write, plus 1, 0, plus 1. F, if you write, 0, minus 1, plus 1. Now, if you observe this, now if you observe this matrix, now if you observe this part, which is of the twigs, if you observe this part of twigs, so Q can be written as Q twig and Q link. But if you observe Q twig 1 0 0 0 1 0 0 0 1, it is an unitary matrix. It is an unitary matrix. In this way, you can identify if the solved question is correct or not. Good evening, Rashekar. So this is how you will get the solution for the Cutset matrix. So this is one problem that we have solved. Now let us also consider one more problem and try to find, first we'll try to find what is Cutset matrix, then we will try to find what is first we'll try to find what is Tieset matrix, then we'll try to find what is Cutset matrix. So the question is something like this. I'll directly give you graph. So let us suppose this is the given graph. Let us suppose this is the given graph and these are the nodes. And this is A, B, C, D, E, F, and G. And let the nodes be 1, 2, 3, 4, 5. Let us suppose this is a given question and we are asked to find what is, find first Tieset matrix. Let us say Tieset matrix for given tree. So for a tree we need a Tieset matrix. Sorry, for a Tieset matrix we need a tree. First let us write what is the number of nodes. N is equal to, how many number of nodes are there? 1 2 3 4 5. 5 nodes are there. Next write number of branches, total branches I'm writing. What is number of branches? B is equal to A, B. Let us write this as 1 2 3 4 5. And branches, let us write branches A, B, C, D, E, F, G. How many are there? 1 2 3 4 5 6 7. 7 branches are there. Now number of twigs, let us write number of twigs. How many number of twigs we should get? Let us first calculate that. It is n minus 1, that is 5 minus 1. 4 twigs you have to get. Check whether they are, all these dotted lines are links, all these dark lines, blue color lines are twigs. A, B, C, D. So A, B, C, D are twigs. Now next write number of links. Number of links also will try to find. B minus n plus 1. What is B? 7 minus n 5 plus 1. It is 3. So what are they? Let us see. E, F, G. So E, F, G are links. E, F, G are links. So now let us see if E, F, G are links and these are the branches. Let us try to find, let us try to take this to the next slide and find Cutset matrix. Now if this is the question. Yeah, this is the question. Let us take this as little bigger. Now we need to, now what are the, what is a Cutset matrix? Cutset matrix is represented by B, and what is the size of the Cutset matrix? The size of the Cutset matrix is number of links B minus n plus 1 by B. So B minus n plus 1, what is that we got? B minus n plus 1, 3, and by B is 7. So 3 by 7 is the size of the matrix. So you'll get here I1, I2, I3. So let us write first Cutset matrix, right? So Cutset matrix is dependent on links. What are the links in this case? Links are E, F, G. These three are the links. How many links are there? Three links are there. E, F, G. So when you place E, there is a loop that is forming. So take that loop direction. So there is a loop that has formed, and take that loop direction. So this is the loop. So let us call that as I1. Now the other one, F is the other link. So add this F here. To add this F here, there is another loop that is forming, and you must consider this current. This as I2. How we are taking the direction of this I2? I2 must be in the direction of F. I1 must be in the direction of E. That means the direction of the loop current must be in the direction of the link. Now third one, third link is G. If you add this and try to do this, you'll get this. So this is actually C. So this is I3. Now let us observe what is I1 loop, I2 loop has, I3 loop has. I1 is nothing but Cutset 1, I2 is Cutset 2, I3 Cutset 3. So in I1, what do you write? I1 has these three branches E, B, C. So let's write B, C, E are the branches in I1 cuts Cutset 1. Next, take the Cutset 2, this part. If you see A, B, F, A, B, F, and Cutset 3, C, D, G, C, D, G. Now let us write all the values. Let us write all the values in I1. This is 1, or this is A, B, C, D, E, F. Now is I1 and B same direction? A is 0, B, C, E are there. B, C, except B, C, E, rest of the values are zeros. Now is B and I1, is I1 and B in the same direction? I1 and B are in opposite direction. So this is minus 1. Is I1 and C in the same direction? No, in the opposite direction. So this is also minus 1. E will always be in plus direction. Now let us take I2. Is I2 and A in the same direction? Is I2 and A, no, opposite direction, minus 1. Is I2 and B in the same direction? No. See, if you observe, I2 is in upward direction, B is in downward direction. So it is also minus 1. Is I2 and C? C does not exist in this loop. Is there a C in this loop? No. Is there a D in this loop? No. Is there a E in this loop? No. Is there a F in this loop? Yes, it is in the same direction, plus 1. Now let us consider I3. I3 has C, D, G. Except C, D, G, the rest of the values are 0. Except C, D, sorry. Yeah, we also need to take G here. A, B, C, D, E, F, G. So this is 0 again. So this is also a 0 again here, because 3 by 7, 1 2 3 4 5 6 7. So let me write it clearly. Yeah, this is 3 by 7 matrix. Yeah, I'll take this. So now this is E F G. So this value is also 0, because in the first loop you don't have G, and in the second loop also you don't have G. This value is also 0. Now if you take the third loop, now I3 has a C D G. Except C D G, the rest of the values are zeros. The rest of the values are zeros. Now write these values. Is I3 and C in the same direction? I3 and C are in the opposite direction. 0. Sorry. I3 and C are in opposite direction. -1. Is I3 and D in the same direction? Is I3 and D in the same direction? I3 and D are also in the opposite direction. Is I3 and G in the same direction? Yes. So this is how you will find matrix, Cutset matrix. So today we have learned what is Cutset matrix and what is Cutset matrix. Cutset matrix is represented by B. Cutset matrix is represented by Q. Cutset matrix depends upon number of links and size is b minus n plus 1 by b, and Cutset matrix will depend upon number of twigs and the size of the matrix is n minus 1 by b, and the direction of this links, direction of loop currents or Cutset is in the same as the direction of links, and the direction of Cutsets are in the same direction of the twigs. So with this, graph theory is completed. Also we have completed circuit theory crash course. We have completed circuit theory crash course. Thank you all for once again for your great support. G. Balraj, hi sir, matrix concept I am understanding easily. Thank you, Balraj. Thank you so much. So with this, we have completed circuit theory crash course. Thank you all for your great support. So as I always tell you, we have India's #1 study channels. We have so many study channels under Unacademy and also Unacademy Semester Exams. And please do like this video, share this video, use this referral code, use my code YSK10 to get maximum discount. Subscribe to this channel and click on this bell icon to get notification of my classes. Thank you all. Thank you once again for joining me for this today's session on graph theory and the end of circuit theory crash course. Thank you all.